Today's project is to install the Siklu Terragraph distribution node at one of our downtown points of presence buildings. This particular building currently has three 60 gigahertz multi-point antennas on it from various vendors. It is serviced by an Etherhall 1200 connected to a building directly across the street where we have access in redundant paths at 10 gigabits to the internet. So this is one of our core downtown areas. The hope is the installation of this Siklu Terragraph will be able to replace not only the three multi-point 60 gigahertz APs that are currently on this building, but an additional two 60 gigahertz multi-point APs on the building directly across the street, allowing us to connect to between 8 and 10 buildings directly off the Terragraph distribution node. We service a couple of apartment buildings. We service some small businesses along what is our main street. We have a couple of nonprofits that connect to this, as well as various MDUs that are in the immediate area. So it is one of our primary points of presence. We have gotten enough 60 gigahertz in the area now that we are seeing our own self-interference, and we have just too many APs to really be able to manage them effectively. So we hope by the end of this test we will be able to eliminate between 5 and 6 different multi-point APs in the downtown area and replace them all with one Terragraph AP, which will make channel planning a lot easier. It'll make our self-interference likely go away, and it will also allow us to keep one SKU on hand for replacement and new installations. Okay, we covered the unboxing in a different video, but now we're going to cover the assembly of the unit. So we'll take off the top. It does come with straps large enough for a 4-inch pole. Our pole is much smaller, so we're going to go ahead and use a different set of straps. One thing to note, the standard bit driver on our screwdrivers does not fit properly on the straps that come with the radio itself. So let's get the straps on the mounting plate. And I'm going to mount these straps on the bracket in advance to make it a little bit easier to slide the bracket on, and so that I know I'm not going to be fighting the bracket later on when I'm up on the roof. Okay, we've got those started. Now we'll get the radio itself out. And as we mentioned, we've got the mounting plate that's going to line up with these screws. And these screws are designed to not fall out. Very nice. Let's see, we're going to go screws up. No, I was right the first time. Screws go down. There we go. So it ends up kind of hanging off the bottom of the radio once you've got these guys lined up. Something else we've noticed, again, does not fit our standard bit driver, so we're forced to go to an adjustable to get these all the way on. So we've got the radio attached. It does have kind of a handhold at the top, so when we get up to the top part of the roof and we slide this down over the top of the pole, we are able to hold on to it to make the final adjustments on it. All right, here we are up on the roof where our distribution node is going to get mounted. You see we've got a couple different point to multi-point radios up here now, as well as a 5 gigahertz. We've had to move those down temporarily to make some room here at the top of this pole so that we can mount the distribution node. Once it's up and running and the test is complete, we'll be able to take the majority of these radios down. So we'll go ahead and mount the radio now on top of that pole so we get the full 360 degrees. So we're going to get it tight, and we know using Google Earth where we need radio 1 to be aimed for. So at the bottom of the radio, there is an arrow that points in the direction of the center of sector 1, and we know where we need that to go via channel planning. So now we're just going to twist the radio slightly so that it lines up with exactly where we need it to aim, and then we'll continue tightening it down so it's perfectly locked off, and the next step will be to connect our cables. Alright, so our next step is we're going to connect both fiber and Ethernet to the distribution node. We've decided to use fiber with a single mode BiDi optic in there for 10 gig connectivity down to our switch. So we'll connect the fiber in first. That's going to have all the data and management traffic on it. And then the second connection is going to be the copper Ethernet into the PoE number 1 port, and this is only for power. There'll be no data traffic on that guy at all. Alright, the last step of any good installation is we're going to complete the ground. So we've taken out the Siklu ground cable, we've attached it to our mast, which is well grounded. The ground port is very accessible on this, especially in the direction we ended up having to aim it. There we go. One well grounded distribution node ready for customer installation. Before we head up onto the roof, I wanted to show a couple of things here in the shop that's just easier to do before the radio is up on a pole. On our right, this is a multi-hull client radio, and on our left is Terragraph T265. If you are doing a like-for-like replacement between these two radios, like we are at a couple of our sites, you'll notice the mounting bracket for the two radios is identical. So if you want to simply remove the hex screws on the side of your multi-hull radio, those will then fit in to the same exact spots on the Terragraph radio. When you line these up next to each other and you put the mounts directly in line as if you were going to replace just the radio and leave the mount on the pole, you will notice that the Ethernet connector is further down on the multi-hull than it is on the Terragraph T265. So you're either going to end up loosening these straps and sliding this radio down, or you're going to pop some zip ties and extend this cable by about 1.5 inches so that it will get up to the position it needs to be. On the multi-hull radios, if you're familiar with those, on the side you've got your power light, your 3 Ethernet lights, and then the very top is your RF light. They've changed that a little bit on the T265. You have a green light on the bottom directly next to SFP1, or Ether1 rather, that's going to tell you that you are receiving power up this cable and the radio is powered. When you first plug it in, it'll be orange, and then once it is powered up and booted and has a negotiation with a device at the other end, it'll go green. Your RF light is over between the SFP plus port and the USB port. So this guy here is going to light up green when it has an RF link to a DN at the far side. There are no lights on the sides of this radio. You've got to get underneath to see your power and your RF. So we're going to replace a client node here. What we've got at this particular node is a Siklu multi-hull client going back to the very same tower that we've installed the Terragraph distribution node on. So we're going to take this node, we're going to just slide it down the pole for now for our testing purposes, disconnect the Ethernet. We've got a Siklu injector at the bottom, so everything is going to be real easy to swap out. We'll get it out of the way, and then right over the top of the pole there, straight ahead off in the distance, is the distribution node for the Terragraph. And we've changed out our hose clamps for ones that are probably just barely going to work on this 2-inch pipe here. There we go. That's got a nice fit to it.
Make sure our cable reaches.
So this is a site where we're just going with the PoE copper. Goes down to an injector, and then we control the router at the other end. And because it's Siklu to Siklu, everything fits nicely. We will aim this guy manually over to the distribution node. And then tighten her down. That's as simple as it is installing a terminal unit.